Alright guys, this is our Quadratics test review. I figured I'd go ahead and make a video that works everything out in case we don't get everything done in class, or in case there's parts of class that were confusing, you can kind of re-watch and go back over. So let's, without further ado, just kind of jump into things here. So the first thing is labeling our quadratic. That should be relatively straightforward. We're just going to label like the vertex, the axis of symmetry, zeros, all that good stuff. So to correctly label this, move this a little closer. To correctly label this, this would be, these are the zeros, also known as solutions. Okay, they're x-intercepts, they're roots as well, but I think zero solutions are the two most common ones. This is our axis of symmetry. I know it's yellow and I know it's terrible to see, but at least it kind of matches the line, so it's kind of cool. You know, I do things sometimes. That's our axis of symmetry. It's the line that slices right down the middle. Okay. This is our vertex. That's a terrible shade of green, but that's the color that's sitting over there. Vertex is also known as our max or min. In this case, it would be a minimum, given the fact that our vertex is at the very bottom. So, but our vertex is the point here, the very edge of the parabola, the very turning point of the parabola. I guess we could just do this. Purple, this is our y-intercept, because it's basically, you know, where our, you know, quadratic hits the y-axis. Not one that we focus on a lot, but it is still kind of a point of reference to note. All right, so let's move on to identifying solutions, vertex, axis symmetry from the graph. So if you already have the graph, it's pretty simple. So solutions, remember solutions are zeros. They're the x-intercepts. These are the solutions. Now solutions in this case are at -4 and also at 0, right? Because this is 0 here, and this is -4 there. All right, our vertex is the very turning point of the parabola. It's this point up here. If we follow this order pair is -2 for x and +4 for y. Our axis of symmetry is this splice right down the middle, right? Which goes, of course, at -2. So it's x equals -2. So keep in mind the axis of symmetry is always the same as the x value in the vertex. You'll notice that on all the other ones as well that I do here. And our max or min, our highest point is up here at 4 on our y-axis, right? That's our max because it's the highest, and it's at y equals 4. So our max or min is always the y value of our vertex. So you'll see that those match every time. Essentially right here, you know, this stuff is your vertex, just kind of broken up individual parts. Solutions on the second part, solutions again are the x-intercepts. So you can see it crosses here at 2 and at 6. Our vertex is the turning point, the very top or bottom of our parabola. In this case, it's at x equals 4 and y equals 2. So vertex is the point 4, 2. And then our axis of symmetry is the line that goes right through the middle of this. And as you can see, it's right at x equals 4. It's always the same as that x value of our vertex. And our max or min, our maximum, because it's the highest point here, is y equals 2, because it's all the way up the y value at 2. So again, these two should be the x and y of our vertex. And they are. And then our final graph here, our solutions are -2 and 1. So x equals -2 and x equals 1. Our vertex is a little bit odd, but I would venture to say it's -0.5 as our x, because if you trace this up, it looks like it's about -0.5. And about maybe -3.5 for the y, if you trace it across to the y. So our axis of symmetry, remember that line that slices right down the middle, of course, same as the x value in our vertex, so it's also x equals the -0.5. And our vertex, or sorry, the max and min, it's a minimum in this case since it's all the way at the bottom, and it's about y equals -3.5. All right, you can pause the screen if you need more time on that, but I'm going to move along. So here, now this is important because we have to show our work. So make sure you know these formulas, okay? So remember, the axis symmetry formula is negative b over 2a. We're going to use this for all 4 of these problems. So in my first example, a is negative 1, because that's my a value. B is 6, and c is negative 4. I don't really need the c value to find the axis symmetry, but it's worth noting. So my formula, using negative b over 2a for this example, would mean I have negative 6, since 6 is b, and the negative is part of the formula. 2 times a is negative 1. So I just plugged in 6, and I plugged in negative 1, and if I evaluate, this becomes negative 6 over negative 2, which simplifies to a positive 3. So my axis of symmetry is x equals 3, positive 3. Now, to find the vertex, keep in mind that the axis symmetry, that x value, is always the same as the x value in the vertex. So I already have half my vertex. If I want to find the y value, I would just plug in this x value back into my function. So when I plug it in, I'll have y equals, and I have negative. Now be careful, because when you plug it in, you want to put it in parentheses. So put this in parentheses and square it, plus 6 times 3, again put it in parentheses, minus 4. So you can type this in the calculator, or you can do it by hand, but either way, we end up, I believe, I'll do it by hand, this would be negative 9, because 9 squared is, or 3 squared is 9, and then you got the negative from the outside there. This would be 18, and this would be minus 4, so I think that's 5, maybe. Yeah, negative 9 plus 18 is 9. Minus 4 would be 5. Okay, hopefully I did that right. Kind of did it quickly, but I believe that's right. All right, so all of these kind of repeat that process. I'm going to erase this so that I can start fresh on the next one. But for number 6, the axis symmetry formula, negative b over 2a. b is negative 64. So if I do negative b, then I'm really going to have a positive 64, because these two negatives here are going to cancel out. So, but let's do over 2 times a, which is negative 16. So I really have a positive 64 over negative 32, which is negative 2. So this is my x value. This is my axis of symmetry, but it's also the x value of my vertex. So now if I plug in negative 2 into this function, I'll get the y value of the vertex. So that would be negative 16, and we would do negative 2 squared. Again, plug that in parentheses. Minus 64 times negative 2 plus 81. I'll let you guys work that out. I don't know that off the top of my head. I don't have a calculator on me either. But if you type that in the calculator exactly as I wrote it, you should get your y value. Okay? So in number 5, there is no c value. We have a, because that's the x squared part. We have b, because that's the part that's with x. And there's no constant at the end. There's no term that doesn't have an x, so there is no c term here. So your negative b over 2a would be negative 8 over 2 times negative 2, which would make this negative 8 over negative 4, which results in a positive 2. So x equals a positive 2. Remember, that's the same as the x value of the vertex. Plug 2 back in here for x, and you'll get the y value of your vertex. So this would be negative 8 plus 16, which would be a positive 8 as a result. Okay, 7 works the same exact way. I'll let you do that one on your own, just for the sake of saving a little bit of time here. But now let's solve each quadratic. So for number 8 and 9, our quadratics are already factored, and they're already set equal to 0. So our goal basically is just, what makes x minus 1 equal to 0. Oops. Let's try that again. All right, x minus 1 equal to 0, and what makes x plus 3 equal to 0. You just take each part here, each factored binomial, and set it equal to 0, and solve for x. So here, if you add 1 to both sides, we'll have our x equal to a positive 1. And here, if you subtract 3 on both sides, you'll have x equal to negative 3. So the two results are positive 1 and negative 3. On number 9, it's very similar. It's already factored, so just take each thing in parentheses and set it up equal to 0. Again, need to start over that one. So 3x minus 7 equal to 0. We'll solve this for x. We'll do the same thing for x plus 3. We'll set it equal to 0, and we'll solve for x. So let's do this one first. Add 7 to both sides. This will be 3x equal to 7. And then you divide by 3. We'll get x equal to 7/3. You can just leave the fraction alone. You don't have to change it to a decimal. And then for the other one, subtract 3 on both sides. We'll have x equal to negative 3. So there are your two answers, negative 3 and 7/3. Now for the rest of these, we have to factor them. Now number 10 is simple enough to factor. There's only 2 terms. So I'm going to try first a GCF and go from there. So I'm looking at these 2 terms and I'm wondering what they have in common that I can divide them by. Both of them are divisible by 3 and both of them have an x as well. So we'll take 3x, we'll factor 3x out, and that leaves me with x plus 6 remaining. The 3's here cancel. There's only 1 x remaining when there's 2 originally. 18 divided by 3 is 6, and those x's have canceled. So remember that this is equal to 0, so we have 2 parts equal to 0. We have 3x equal to 0, and we have x plus 6 equal to 0. So when you solve these, dividing by 3, you still get x equal to 0 for this first part. And for the second one, when you subtract 6, you get x equal to negative 6. So our 2 answers would be 0 and negative 6. Now number 11. A little trickier because we have a trinomial, but the first thing we should try is a GCF. Is there a GCF that these 3 terms have? The answer is no, so let's factor it. Now, when we have 3 terms, we have a trinomial, we use our product and sum. So that means, the x thing, what 2 numbers multiply to something and add to something else. So a times c. A is 1, c is 16. So 1 times 16 is 16. We're going to need that number. B is negative 8. So the puzzle I'm trying to solve here is what 2 numbers multiply to 16 and add to negative 8. Give you a moment to think. If you want to pause the video, you can. But I'll go ahead and tell you the answer. It's negative 4 and negative 4. Negative 4 times negative 4 is 16. Negative 4 plus negative 4 is negative 8. So that means my factored, I will use these as x terms to replace the middle x term here. So we'll write this quadratic again, x squared, but instead of writing minus 8x, I'm going to write minus 4x minus 4x. I'm using these 2 terms here. And then plus 16 at the end, that doesn't change. It's just the middle part is what changed. So now you factor by grouping. So you group the first 2 terms and the last 2 terms together. The first group has an x in common, so the x gets factored out. And when you factor it out, we have x minus 4 left. My second group, both are divisible by 4, but I'm going to divide it by a negative 4 because when I take a negative 4 out, that makes the first term just x and the second term a negative 4. So I get this binomial to match that one. So my answer, my factors are x minus 4 and x minus 4. Now again, both of these equal 0. So you would take them, and I'll just move it up here, and set them equal to 0. Now since they're both the same, I'm not going to solve it twice. That would just kind of be wasteful. But you add it, add 4 to both sides, we get x equal to 4. And of course, we'd get the same result if we did it again with the other x minus 4. So our answer is simply just x equals 4. Number 12. Number 12, again, it's a trinomial. Look for a GCF first. Notice there is not a GCF. So we will use our product and sum method. So a times c. Notice a is 3, and c is negative 4. So 3 times negative 4 is negative 12. Our b value is negative 4. So now let's solve this puzzle. What two numbers multiply to negative 12 and add to negative 4? If you want to pause the video to think, go ahead. And I'll go ahead and tell you the answer is negative 6 and positive 2. Now remember that these become x terms, and we're going to use them to replace that x term. So we'll have 3x squared, but instead of the minus 4x, we'll put minus 6x plus 2x, and then keep the minus 4 at the end. So now factor by grouping. The first group has a factor of 3x, so you can take 3x out, and that would leave you with x minus 2. And the second group has a factor of 2, so you can take 2 out, and you'll have a leftover of x minus 2. So your two factors are 3x plus 2 and x minus 2. Remember that these are set equal to 0, so take each of them, set them up equal to 0, and solve for x. So for this one, you would subtract 2, would have 3x equals negative 2, divide by 3, and you'll have x equals to negative 2/3. This one's pretty straightforward. You add 2 to both sides, and you'll have x equal to positive 2. So there are your two answers for that one. So 13. 13 is only a binomial, but again, let's always look for a GCF first. I notice both of these are divisible by 4, so I'll take the 4 and factor 4 out. That leaves me with x squared minus 16. Now, what's interesting here is that this binomial is still factorable. If you notice, it's factorable using difference of squares. So when you factor by difference of squares, all you need to know are the square roots of each. So square root of x squared is just x, and the square root of 16 is just 4. Right? X times x makes x squared. 4 times 4 makes 16. So we'll just pair these up. We'll have x plus 4 and then x minus 4 as the factors. So it's always just the square roots paired together, one with a plus sign, one with a minus sign, and there's your factors. There is still technically this 4 on the outside, but because this equals 0, this 4, of course, will never be 0. It's just these two things. So set them up, x plus 4, set it equal to 0, and x minus 4, set it equal to 0, and solve. So this one, you subtract 4, you'll have x equal to negative 4. This one, when you add 4, you'll get x equal to positive 4. So there are your two solutions. Okay. Now number 14 is kind of a trick question. It's not a trick question, I suppose, but it's a complicated look. But let me kind of break it down simply for you. So 4x plus 6y, I'm going to use this space over here on the left. 4x plus 6y squared just means 4x plus 6y times itself, 4x plus 6y. Now, if you're going to multiply these things together, then what you would end up doing is foiling. You would take the first term times the first term, which is 4x times 4x. First term times the last term, which would be 4x times, I'll put these in parentheses, 6y. Then you would do the inside terms, so that would be 6y times 4x, and I apologize for kind of curving it a little bit here. And then the last terms, 6y times 6y. Now, there's a reason I didn't actually go ahead and multiply these together. You know, I know that 4x times 4x is 16x squared, but I've written it like this because you'll notice, you know, I'm trying to compare one of these four options to what I have written down. Now, if you notice, here, 4x times 4x, well, that is 4x multiplied by itself. That is 4x squared. Here, I have two versions of the same thing, 4x times 6y. So I have two versions of 4x times 6y. And then this last part, I have 6y times itself, which means 6y squared. So that matches answer choice C. Now, you might not have known to do that, and that's okay. So what you could have done differently, but still kind of the same, is just when you multiply these out, maybe you actually multiplied them all out. 4x times 4x, you wrote 16x squared. 4x times 6y, you wrote 24 xy. 6y times 4x, you wrote 24 xy again. And then 6y times 6y, you get 36y squared. And that's fine. You can combine those to make 48 xy. And this is all well and good. Obviously, none of the answer choices look like this, but what you can do is just simplify these answer choices and figure out which one matches this. So you can immediately tell that it wouldn't be A because A doesn't have the 48xy part. You can tell it's not B because B has 4x squared and we should have 16x squared. So that at least can kind of narrow it down to C or D. And the only difference between them is the middle part. So if you multiply the middle part, you end up with 24xy for D and 48xy for C. And of course, C matches because we have 48xy here. So you can always, there's ways around it. You don't have to do it the way it was intended for you to do. You can still try to figure out a way to match your answer with one of those answer choices. Now, number 15 is basically the same thing that we just did on the left side where we factored, but to solve this quadratic, we can't actually factor it. So we're looking for the solutions. That means we're looking for the zeros. So with our quadratic, x squared plus 6x minus 14, the first thing I would try is factoring. So I would try to figure out what two numbers multiply to negative 14 and add to 6. But I'll be sitting here for a while because there aren't any numbers that multiply to negative 14 and add to 6. So what do? Well, I could just use my quadratic formula. My quadratic formula is negative b, so that would be negative 6 plus minus the square root of b squared, which would be 6 squared, minus 4 times a, and a is 1, times c, which is negative 14. All divided by 2 times a, which is 1. So if I simplify this, this is negative 6 on the outside, but all this in the middle, this is going to be 36. 6 squared would be 36. This part will be, I believe, 64. Maybe. What is 4 times 14? It's 56. Fair enough. So that leaves you with the square root of 92 then. This wasn't what I was trying to do. I thought I fixed this problem. Anywho, we have that, and then we would divide it by 2. So there is a way to reduce this radical, but we haven't talked about that yet. So what I'm probably going to have to do is just take this problem out or change it for you guys because we haven't learned how to simplify this square root yet. You can, if you want to, go ahead and find the decimal version of this. But ideally, I wanted you guys to be able to simplify this. Can't do that just yet, so we'll let it go for now. All right, but when in doubt, use the quadratic formula. Okay, I apologize for that question not being the way I thought it was. So, in number 16, it's more of a puzzle than it is a math problem. You're trying to figure out what values of x and what value of y could you use in this to basically be the same thing as 52 times 48. And to think of it this way, imagine you have a number line, just to kind of give you a visual. Let's say I put x here, right? X is some number. And let's say y is a distance, right? If I do x plus y, right, then I'll end up here because I'll be adding whatever I'm considering y to be. If I do x minus y, then I'll end up here. Somewhere on the left side. But the thing I'm saying here is that this x thing is all the way in the middle. Because if y is 5, this would be 5 units to the right, this would be 5 units to the left, x would be in the middle. So basically, to solve this puzzle, I have to figure out what's in the middle of 52 and 48. The middle of 52 and 48, if we actually draw a number line for that, 48, 49, 50, 51, 52, the middle of these 2 points is 50. This is my x value. X will be 50. Now my y value, how far am I adding or subtracting? To get to 52, I'd be adding 2. To get to 48, I'd be subtracting 2. So my y value would be 2, because I'd be adding 2, and then I'd be subtracting 2. So, and you can kind of see that when you write it all out. 50 plus 2 times 50 minus 2. That is 52 times 48. It's the same thing, but it's very much a puzzle. And I chose this because it is an EOC question. It is something that was on our EOC review last year. All right, number 17. So keep in mind, we're just looking for the y-intercept of each of these. And the y-intercept is every time x equals 0. Whenever x equals 0, the y value is your y-intercept. So for my table function, x is 0 here, that makes -6 the y-intercept. So h of x, its y-intercept is -6. Okay? So keep that in mind. But what's the y-intercept for f of x? Well, remember, the y-intercept is whenever x is 0. So for f of x, if you put 0 in there for x, then this is going to be 3. This will be 0 plus 2, which 0 plus 2 would just be 2. And 3 times 2 is 6. So the y-intercept for f of x is 6. The y-intercept for h of x is -6. So if you imagine your y-intercept, f of x is way up here at +6. And h of x is way down here at -6. So what's true? A is true, because f of x, it's for saying which statement is true about the y-intercept of f of x. F of x is 12 units above the y-intercept of h of x, because f of x is way up here, and that is 12 units higher than h of x. You can count them up if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? It's 12 units above. So just a little trick there to know is the x equals 0. Okay, so for number 18, it's another one where you have to factor, because it's saying find the solutions, right? It says values of x where the graph of the polynomial crosses the x-axis. So crossing the x-axis, that means finding our zeros. So we'll take this, we can either use the quadratic formula, or we can try to factor it. I'm going to try and factor it first, because that'll be easier, a little bit faster sometimes. So a times c, 2 times -15 is -30, and b is 1. So what two numbers multiply to -30 and add to 1? You want to pause the video and think? You can. If you need a hint, remember one number is positive, one number is negative. If you need another hint, 5 and 6 multiply to make 30. +6, -5 will work for this. So when we solve this, we'll have 2x squared plus 6x plus 5x. Oh, I'm sorry, it should be minus 5x minus 15. And you'd factor by grouping. Now, when you factor by grouping, the first group you can take 2x out of, and you'd have x plus 3. In the second group, you can take -5 out of and have x plus 3. So your two binomials, let me just move them over here, is x plus 3 and 2x minus 5. So remember to set each of them equal to 0 and solve them. When you solve x plus 3 equal to 0, you'll get x equals -3. When you solve 2x minus 5 equal to 0, you'll get x will equal 5 halves, because when you divide by 2, you'll get 5 halves. So x equals -3 and x equals 5 halves. You can use a quadratic formula if you want. I just think factoring would have been a little bit easier there. Number 19. So a ball is thrown upward at a velocity of 20 meters per second from a height of 25 meters above the ground. The height h in meters of the ball at the time t in seconds after it is thrown can be formed by this formula. Find the time when the ball is again 25 meters above the ground. So 25 meters here. It's asking for t. It wants me to figure out what is t. So I'm solving for t here. But I'm solving for t when the height is 25 meters. So this is my h value. This is what I need to plug in for h. 25 equals negative 5t squared plus 20t plus 25. So same equation, but I plugged in 25 for h. Now to solve for t, remember, the first thing I need to do is make sure every quadratic is set up equal to 0. Well, this quadratic doesn't equal 0, it equals 25. It's a pretty simple fix, though. Let's just move the 25 over there. So subtract the 25 on both sides. And that way you'll have 0 on the left. And now 25, it doesn't combine with any of these terms, but it does combine with this. That 25 minus 25 will turn into 0. So this equation will look like negative 5t squared plus 20t. That's what's going to be equal to 0. Because this 25 will cancel out with the other 25 and just leave you with that negative 5t plus 20t. So factor this. You can factor it by GCF. I would factor out negative 5t. So when you factor negative 5t out, then that leaves you with a positive t and a minus 4. So set each of these equal to 0 and solve them, and you'll figure out which t value would be the time when the ball is at 25 meters above the ground. So that would be negative 5t equal to 0. When you divide by negative 5, you get still t equal to 0. And t minus 4 equal to 0, you would actually get t equals 4. So either it took 0 seconds or it took 4 seconds. And the answer is took 4 seconds. 0 seconds was when we threw the ball. 4 seconds is when it returns to 25 feet above the ground. All right, kind of hustle through this a little bit quickly. Apologize if I rushed through it. You can always rewind and watch again or pause it. But here, I got a quadratic, and I'm asked for how long will it take for the rocket to return to the ground. So remember the ground, return to the ground. That's a height of 0. So that means we're going to put 0 in for h of t. 0 equals negative 16t squared plus 192t. So all you got to do is solve this. I would factor it. There's only 2 terms here, so you can just factor by GCF. I'd factor out a negative 16t. Again, I always take out a negative if my a value is a negative. So you get negative 16t, and then I don't remember what 192 divided by negative 16 is, but it'll be something, t minus something, maybe 8 or 9. I don't remember exactly what it was. But whatever it is, just set it equal to 0 and solve, and you'll have your time. For part B, how many seconds will the rocket reach 560 feet? So remember, 560 feet, this is my height. This is what I'll plug 560 in for h. So my equation was still negative 16t squared plus 192t. So remember, to solve this, for t, I have to make sure the quadratic setup equal to 0. So that means moving the 560 to that side. So subtract the 560, and now you'll have 0 equal to negative 16t squared plus 192t minus 560. Now, these should all be divisible by negative 16. So factor that out first, and you should have a trinomial that's a little bit easier to solve. You'll have to use product and sum after you do the GCF, but at least take that GCF out, and your product and sum should be a lot easier. Maximum height. So maximum height, that means vertex. To find vertex, you need to use negative b over 2a. So in this case, b was 192, so you'd have a negative 192 over 2 times a, which is negative 16. So solve that. That'll be your time. That'll be how long, that'll be the answer to this question, how long it takes to reach maximum height. Whatever that number is, plug it back into that function, and you'll actually find out what the height was. So that'll be the t value, that'll be how long, that'll be the answer for C. But when you plug in that value back into t, you'll find the maximum height. I'm going to end it here, guys, because I'm running out of time. But If you have any other questions, let me know. I apologize for the video being too long, but I want to be thorough as well. So I'll see you next time.